collapse load calculation. So we are going to see now this collapse load calculation. Okay, how? How to calculate this collapse load? I will tell you what is required. So that is enough for your examination perspective. The short note concerns. Okay, the state governmental examinations. Okay, first see in the collapse load. First point you need to understand is mechanism. Mechanism means unstable structure. Mechanism means unstable structure. Okay, our unstable structure is called as a mechanism. Okay, next one. Number of plastic hinges. Plastic hinges required to convert indeterminate indeterminate into determinate structure. Indeterminate into determinate structure, which is equal to degree of static indeterminacy, ds. Okay, what is ds? Degree of static indeterminacy. Next one is this is the number of plastic hinges required, right? Now, number of plastic hinges required to convert indeterminate structure into mechanism. Indeterminate into mechanism, then we need ds plus 1. So ds plus 1 hinges we need. Okay. Now we are going to see that is so location of the plastic hinges. So we can write location of plastic hinges. Location of plastic hinges. Okay, so here I will write some more points. This collapse load is analyzed by using upper bound theorem, or kinematic theorem. Upper bound theorem or kinematic theorem and lower bound theorem and lower bound theorem or static theorem. Okay, the collapse load is analyzed by using upper bound theorem or kinematic theorem, lower bound theorem or static theorem. Now here you have to keep in your mind what is the keep in your mind, that is upper bound theorem. Upper bound theorem, that is kinematic method. So in the kinematic method, you have to first see the characteristics. Okay, it satisfy equilibrium condition and mechanism condition. equilibrium and mechanism conditions. So that's the first point. So upward bound theorem which satisfy equilibrium as well as mechanism condition. And the second one is collapse load, the load which is calculated which is greater than or is equal to collapse load. So these 2 points are the characteristics you have to keep in your mind. So you will get a question in the state government examination. Then lower bound theorem. Lower bound theorem or static method. Lower bound theorem or static method. This theorem says characteristics. It is satisfying equilibrium and yield condition. Equilibrium and yield condition. Second point, W, the load which you are getting is less than or equal to WC. So this is our lower bound theorem. In the lower bound theorem, the load you are calculating which is less than or equal to collapse load. In the upper bound theorem, the load which we are calculating is greater than or equal to collapse load. Okay, so that is the meaning. Now we are going to see the location of plastic hinges. Okay, so at what are the points that we can give a plastic hinges? Okay, the first one is at maximum bending moment points. Wherever you find the maximum bending moment, there you can put a plastic hinge. Second one is at a fixed support, fixed and intermediate supports. Next one is third one is at intermediate support. Okay, fixed and intermediate support. Now under the point load, under the point load, point load, except the following cases. Except the following. For example, a cantilever beam. Here there is a point load. Now at this point there is no plastic hinge. Here there is no plastic hinge. So because there is no plastic hinge, we can conclude this is not a at this point there is no plastic hinge will be developed because the bending moment at this point is zero. So okay, bending moment at this point is zero. If the bending moment is zero, then obviously the plastic moment capacity also zero. Okay. The next one is okay. There is a load. There is a load. And these 2 points, there was a plastic hinge. Yes, plastic hinge will be there. Plastic hinge will be there. Okay, but if you extend this somewhere here, this also having a W load. Now here there is no plastic hinge. Here the plastic hinge is absent. Okay, so that's the meaning. Under the point load, except the following. In the sense, under the point load means is not necessary. All point loads are subjected to. Under the all point loads, there was a plastic hinge. No, that is not a condition. Okay, that is a plastic hinge. There was a plastic hinge under the load, except these cases. Okay, these cases means you understood. At this point, there was a load, but there is no movement. And at this point, there was a load, but there is no movement. That's why there is no plastic hinge developed. Next point is, fourth point, wherever cross section is changed. Wherever cross section is changes, meaning suppose there was a beam or is a structural element, okay, any structural element. Now at this junction there was a plastic hinge. This junction, plastic hinge. Plastic hinge will be there. And the next one is fifth one. Wherever material is changes. Wherever the material is changes. Okay. So that means there was a beam or an axial element and it is having there are two material. Okay. Now this is for example steel and this is aluminum. So at the interface, so because of these two different material at this interface, there was a hinge developed. That hinge also is the plastic hinge. Okay, so these are the important point. Location of the plastic hinge. The location of the plastic hinge will be at a maximum bending moment point at a fixed and intermediate support under the point load except the following: whenever the cross section is changes and whenever the material is changes. Okay, now we are going to write the formulas for a collapse load so that you will get a question in your state government examination and central government examinations. Okay, I'm going to write the important formula. The first one is simply supported beam with a point load L by 2 L by 2. So here the collapse load which is equal to PL by 4. Okay, so here the collapse load is equal to PL by 4. That's the first one. Okay, no. The collapse load is 4 MB by L. Now, second one is simply supported beam the U till acting throughout the span. Now, in this case, collapse load is equal to 8 MB by L square. Be careful, L square. Third one. Third one. Collapse load for eccentric load. Okay, this is W kilonewton per meter, and this also W. Okay, let us consider this is W, and this is W. This is A. This is B. Now collapse load which is equal to MPL divided by AB. Okay, this is all about simply supported beam. Second one is fixed beam. Fixed beam with the center point load W. Then the collapse load which is equal to 8 MB by N. But here one more condition that you have to keep in mind, that is this point A, point B, point C. Okay, here the development of plastic hinge is A, C, A, C, B. MP or plastic hinges develops simultaneously. So A, B, C, all 3 points, the plastic hinges develop simultaneously. That's about first beam under fixed beam. Okay, so actually this is 4, right? And the fifth one is util acting through the span, W kilonewton per running meter. Okay, then the collapse load is equal to, we can write this is 16 MB by L square. Okay, 16 MB by L square. Now, here this point is A, this point is B, center point is C. Okay, here A and B plastic hinges develops simultaneously. Okay, after that C. After developing A and B, the plastic hinge will be developed. Okay, after C, plastic hinge will be developed. Okay, after that is A and B plastic hinge will develop simultaneously. After B and A and B plastic hinge will develop at C point. Okay, so that's a point. Sixth one. Sixth one, eccentrically point load, that is W. Okay, so in this case, the collapse load that we can write is equal to, we can write this is, okay, so calculating collapse load is, after doing this, so you will get a collapse load is something like that, 2 MP by L divided by AB. So this is the collapse load. Okay, now so here this is point A, point B, point C. First hinge develop, first hinge, which is equal to at A point. Second hinge develop is equal to, we can say under the load point, always under the load point. Third hinge, which is equal to at the C point. Okay, so this is the order of development of plastic hinge under eccentric loader fixed beam. Okay, be careful. Eccentric loader simply supported beam MPL by AB, but fixed beam with the point load, then 2 MB into L divided by AB. Okay, next one is sound one. Propped cantilever beam with the point load, center point load 10. Then you know that the collapse load, which is equal to 6 MB by L. Eighth one, fixed beam with the util acting throughout the span. Now, now this, the plastic hinge will be developed at a distance of, this you have to keep in your mind, okay? Somewhere here, This yellow is not good. Okay. From the free end to the maximum bend even occurring point, which is equal to 0.414 L, and a collapse load which is equal to 16.656 divided by MP divided by L square divided by L square. So this also a important examination question. For a property candle with the UTL acting throughout the span, then the maximum plastic inch will be developed at a distance of 0.414 L. Then collapse load is equal to 16.65 MP divided by L square. Okay, so this is all about. Okay, this is all about the collapse load that we having seen. Okay, so ninth one, ninth one, eccentric point load. This is W A B. Now for this case, collapse load which is equal to MP dl plus B, the whole divided by AB. Okay, so this is all about the plastic analysis. You just go through it so that you will get an idea. Okay, so this is the short note for steel. Okay,